When I talked about detention, I talked about rooftop storage. We can also use that concept in stormwater retention. Only here, instead of simply seeking to reduce the rate of discharge, we're actually seeking to reduce the volume of discharge by keeping it on site. And so we can talk, in talking about roof gardens, about two different kinds. Intensive roof gardens, which actually put landscape on top of buildings. And we can see in these images that the landscape that's being created on top of these buildings contains trees and has a tremendous bearing capacity. So the structures have to be designed to stand up not only in their own right, but they have to be designed to be able to hold the amount of additional weight that is added by the use of a planting system on top of the structure itself. And you see here three different examples of a kind of a fairly large garden. In this case, that's planted on top of a parking lot. In this case, that's planted on top of a building. And these systems, if the structural dimensions are accommodated, can be a very effective way of storing water on the roof surface and evapotranspiring that moisture back into the atmosphere. The runoff is treated by the plants that are used in creating the rain garden in the first place. We also can talk about something called extensive roof gardens. Intensive roof gardens have a very, very deep soil profile. They might have as much as 4 feet of soil or beyond. Extensive roof gardens are very shallow, and basically it's a skin of plant material affixed to the roof surface. We see several examples. The most interesting one is this little structure down in the lower left, where we can see grass growing on the roof. And so this is the notion of using grass as a system of storing water on the roof rather than allowing it to percolate down off of the roof and flow across the landscape. We can take that same concept to the upper left diagram and see a more extensive roof surface that is treated as a way of retaining moisture on the surface of the structure and then evapotranspiring that moisture back into the atmosphere. And we see other examples here where we have a stepped series of terraces that are stepping down the landscape as the building steps down the landscape. And each of these has a extensive roof garden on it, where we might have at most 6 inches of soil and plants growing in that are going to help retain moisture and evapotranspire that moisture back into the atmosphere. And again, we can see other examples in this landscape. We can compare the roof garden configuration of this structure versus its sister over here and get a sense of using what would otherwise be a barren surface that generates runoff, possibly detains runoff, but does very little to retain runoff. Whereas this garden, it has the capacity not only to store runoff, but to retain it and evapotranspire it back into the atmosphere. Stormwater retention wants to build on treatment redundancy. In other words, we want to be connecting what one person is doing on their site with what another person is doing on their site. And we want to be connecting what's happening in the private landscape with what's happening in the public landscape. So we want to integrate the drainage systems created by individual homeowners into the drainage system that's created for streets and public parts of the landscape. So we can begin to talk about moving water off of rooftops. And this is a plan view diagram of a subdivision that has 2 cul-de-sacs in it with houses around the cul-de-sacs. So we're talking about capturing runoff from the rooftops, moving it through overland flow through bioswales down into a infiltration system. So all of the runoff from this cell and from this cell, or this street and this street, all of that runoff is going down into this infiltration basin and a stormwater detention pool, which then allows for evaporation of the moisture back into the atmosphere. Then there's an emergency overflow should the system capacity be exceeded. So this is the notion then of building redundancy into the treatment system throughout a site, and thinking about site as more than just one residential site, but thinking about site as neighborhood, and doing neighborhood design rather than individual site design, and doing urban design as a compaction or a collection of neighborhood designs. Here is a detail of that system that I just showed you, where all of the moisture coming, all of the runoff coming out of this street's landscape and this street's landscape is being run through this open channel system, open swale system, into an infiltration and retention system.